So children, now I am going to show you how a genius student might solve this problem, question number 36, MCQ paper 2019, Physics new syllabus. So in this question, the first ball coming into the system has the mass m and velocity v. So the initial momentum is just mv. Whatever the collisions occurred doesn't matter. Now we have to check whether this momentum is there after all the collisions when they move away. So the final velocities are given in all answers, so therefore we have to check all these answers whether this momentum is there. So they say in this first answer, after all the collisions only this ball moves to left with a velocity v. So we have to check. So this one is the final system. So we have to check the system whether it has this value for momentum. So let's check the first one. The mass is m, the velocity is v. So we get the value mv for this direction. But initially the direction was to right. So we get the direction to left in this first answer, so that is therefore wrong. Since the direction is wrong, however, it is wrong. So then we can conclude that this first answer is wrong. So let's check this third one. So let's go along this way. Let's check this third one now. So the final velocity of this 2m ball is this one, to this direction. So therefore we take this direction to right side as positive, because this momentum is a vector. Therefore we write 2m times is the mass. We just write the multiplication of mv. So 2m is the m, v is this value. So 2v divided by 4. When you simplify, 2 times 3, 6 mv divided by 4, then simplify 3 mv divided by 2. So this is the value to right side. So we have to subtract this value because that is to left side. So mass is simple m, velocity is this one. So just multiply that 2 and subtract it from this one. M we divide by 2. So we have to simplify. So like this can simplify. So we get mv to right side. So that is correct. Therefore the initial momentum was mv to right side. So this answer is correct therefore regarding momentum. Then the same way let's check this one. So we take first the momentum to right side as positive. So the m value is 2m, velocity value is 5v divided by 6. So minus this momentum, the m value is simple m, velocity value is 2v divided by 3. So we have to simplify this. So this way I simplified it. So we get mv to right side. So therefore this one also correct regarding only momentum. Then let's check this one. So let's take this one to right side because it is positive. M value is 2m, v value is v divided by 2. So we get mv to right side. That is the only momentum, that is the only ball that is moving, no other balls are moving, so this is the final answer. So that is correct. mv, the value is mv, direction to right side, the same thing, initial equal to initial momentum. So therefore this one is correct. Now let us check this fourth one. Let's first take the positive value. The m value is 2m, v value is 2v divided by 3, so minus this value. M value is simple m, this one. V value is v divided by 3. So let us simplify. Okay, I simplified. That is also correct. We get mv to right side. So this one correct. Fourth one. Now let us check the kinetic energy, because they say this collision is an elastic collision. However, whether it is elastic or inelastic, we can apply the momentum theory, which we did using green color. Since this word is there, now we can use the kinetic energy, whether it is equal to the initial value after the value after collision. So let's take first this one. Only this ball is moving, so the kinetic, before that we have to check, we have to take the initial kinetic energy of the first ball. The first ball coming into the system with mass m and velocity just v. So the kinetic energy initially half m v squared. So we have to check whether this value is there after collision. So let's check it from answer to answer. Since this kinetic energy is not a vector, it is just a scalar, therefore we don't have to take positive and negative sign. All the directions, whatever the directions, no matter, we have to add them, because this one is a kinetic energy, this one is a kinetic energy, no direction it has, therefore we have to add it to get the final value. So in the first answer they say this mass simple m moves to left with the velocity, left or right it doesn't matter, so just half m v squared, half m v squared. So it is correct, it is equal to this one, which I have written in red color. So this one is correct. Then let's check this third answer. Half, this one I take first, mass is 2m v squared, half m v squared, so 3 times 3 9 v squared divided by 4 times 4 16, plus this value, plus remember, because these are vectors, not vectors, scalars, therefore no direction we have to consider. So half m value is this m, simple m, v value is this value, we have to get the square of it, so v squared divided by 2 times 2 4. So simplify. So I simplified, we get the value 10 divided by 16, that is not half, we must get half, then mv squared is there, so we don't get the initial value, therefore this what we checked, the second one, no? Second one, yes, v squared divided by 4, no, yes, second one, this one, 3 became 9, 4 became 16, this second one means this third answer. So this one, what happened wrong, 10 divided by 16, to be half it must be 8 divided by 16, so it is not the answer, we got 10 divided by 16, so it is therefore wrong, this one is wrong. So let's check this one now. So let's first write this one. Half mass is 2m m, then v squared, 5 times 5 25, v squared 6 times 6 36, plus this value plus not minus, half m 4 v squared divided by 3 times t 9. This so I simplified like this, not difficult, simple mathematics. So we get 33 divided by 36, that is not half, we must get half to say it is correct, so it is wrong, therefore we don't get the initial value, therefore this one is wrong. Now let us check this answer. Only this ball is moving, therefore easy. Half 2m v squared divided by 2 times 2 is 4. We have to get the square value of this velocity. V divided by 2 is going to be v squared divided by 4. So simplify, we get quarter mv squared, so that is wrong, therefore we must receive half mv squared to say it is correct. So it is wrong, therefore this one wrong. Now let us check this final one. First let us write this one. Half mass is 2m, velocity squared 2 times 2 4, v squared divided by 3 times 3 9, then plus this value, half m v squared divided by 3 times 3 9. Simplify. Okay, I simplified, easy, not very difficult. So you can pause the video and see all the lines. So we get half mv squared. So initially it was half mv squared, so finally also half mv squared. So this one is correct. So green color correct mark and blue color correct mark, the both is here in the answer 4. Others have only one, either blue color or green color. Therefore this one is the correct answer, children. The fourth one is the correct answer for this question. So I think you understand, you can understand. So thank you very much, then see you tomorrow. Goodbye.